Dear students, very good morning. Today we are going to discuss about hazards. So we have two types of hazards, static and dynamic hazards. So let's discuss what is hazards and how these hazards are affected in the digital circuit. Okay, so what is mean by hazards? So whenever undesirable or unwanted transition in the output of the signal digital circuit, then we can call them it is a hazard. Hazards are unwanted switching transient that appear at the output of the circuit. So due to different propagation delays of different path. Here transition means unwanted switching which appears in the output. So where it is appeared in the output. The mainly hazards are called unwanted switching. Will be very short in duration like a glitch that will be removed after some time. So what is mean by hazard? Hazard is nothing but it is a undesirable or unwanted transition in the output of the digital circuit. So it is called hazard. So I hope you understand what is hazard. Okay. So next, hazards in a combinational logic circuit. So here we have a combinational logic circuit and or circuit containing static hazard. So where is the static hazard is given means it is obtained in the B input. So we have a B and then it is connected with the NOT gate. Here 1 to 0 transition, 0 to 1 transition. That means 1 changed into 0, 0 changed into 1. So this unwanted switching or unwanted transition is called hazard. Okay, so next one is the classifications of hazard. So hazards are classified into three types: static hazard, dynamic hazard, and essential hazard. In static hazard, we have two types: static 1 hazard and static 0 hazard. So let's discuss one by one. What is mean by static 1 hazard? In response to an input change and for some combination of propagation delay, a logic may go to 0 when it should remain constant 1. This transient is called static 1 hazard. So it always it's static at 1. So that's why it is called static 1 hazard. Next one is static 0 hazard in response to on input. So what response? Input response change and for some combinations of propagation delay, a logic circuit may go to 1 when it should remain constant at 0. So the output must goes to 1 but it always constant at 0 means that it is called a static 0 hazard. So I hope you understand what is the concept of static 1 hazard and static 0 hazard. Static 1 hazard should remain in the 1, static 0 hazard should remain at a 0. Okay, so that is the main difference between static hazard. So static hazard has a two types: static 0 hazard and static 1 hazard. Okay, so next one is dynamic hazard. So what is mean by dynamic? Dynamic means it's change. Okay, so when the output of the logic circuit is changed from 0 to 1 and 1 to 0, these two outputs may change more number of time. That means the 0 to 1 transition and 1 to 0 transition, two outputs may change more number of time means this transient is called dynamic hazard. Here the transition 0 to 1 and 1 to 0 is changed more number of time. So that's why it is called dynamic hazard. How to eliminate hazard, static hazard in the digital circuit? So we can avoid this, we can eliminate this hazard by adding redundant terms in the logical expression. So our logical expression is a b bar plus BC. We add extra term, that is AC. This extra term is called redundant terms in the logic expression. So this AC, this A, this is the A and this one is the C. Okay, this AC will remove the static hazard in the circuit. So this is the K-map expression derived from the K-map, and this is the logic circuit with the redundant terms. So by this adding this redundant term, we can eliminate the hazard, that is static hazard. Okay, so next one is the essential hazard. Why it is called essential? So another sort of hazard which will occur in the asynchronous sequential circuit. So where it is occurred? Asynchronous sequential circuit. So what is mean by asynchronous sequential circuit means the clock is different. I mean, clock is different in separate time. That's why it is called asynchronous sequential circuits. So this type of hazard is caused by unequal delays along two or more paths that originate from an equivalent input. So where it originate from an equivalent input. So this type of hazard is caused by unequal delays. And excessive delays through an inverter circuit as compared to the delay related to the feedback path may cause such a hazard. So essential hazard is occurred in the asynchronous sequential circuit. Okay. So what is mean by races and shut up and hold time violations? Hazard can be caused by races. So what is mean by races? Which occur when there are multiple paths for a signal to reach their destination. So when there are multiple paths for signal to reach their destination and the timing difference result in undesired effect, that is called races. These are timing issue that occur when the input to a flip-flop changes to close to the clock edge. Setup time is the minimum time that data must be stable before the clock edge, and hold time is the minimum time the data must be stable after the clock edge. So we have a two time, setup time and hold time. Okay. So next one is assessment. Students, now it's the time for assessment. So what is mean by unwanted transition in the dash of digital circuit? So what will come here? The output of the digital circuit. Then we can call it as hazard. Unwanted transition in the output of the digital circuit. Then we can call them as a hazard. So what are the types of hazard? Hazards we have a mainly three types: static, dynamic and essential. Okay. So thank you students. I hope you understand the concept of hazard. So thank you all. Have a great day.